I would like to explain the vaccine efficacy information. I think this is really important, especially when we are dealing with real life data. I think this piece of information is causing a lot of confusion. And I think the way we are measuring the efficacy may not be uh, representing the actual effect of the vaccine. Say I have two group of people. You can consider these as people, and here there are 12 people. Here there is 12 people. So this group of people are unvaccinated. This will gonna be vaccinated. So in 2 months period of time, we found that there are 3 people have COVID. Okay. So from here, say for example, 3 people got COVID in 2 months period. During one vax, 2 people got the COVID, and 1 people got after double dose. So yeah, so this one got the virus when uh, he got the two vaccine. So basically, same amount of people, say similar amount of people got the virus. But if you look at the traditional efficacy measurement, you will end up seeing that the vaccine efficacy is a certain percentage, a little bit, a certainly higher percentage. I'll show how. So let's isolate this for the time being. I'll show the equation here. So the total population is vaccine population is 12. Total vaccine population is 12. So people got affected in the unvax group, 3, this 3, and in the vaccination group during one dose, 2, and after 2 doses, 1. So traditional efficacy measurement will tell you that vaccine efficacy is 66%. The way they calculate is they find first the risk in unvaxxed people. So risk how do they do that? Just number of COVID patient, 3 by total number of population, 12. That means 1 by 4. Risk in vax people, that means after 2 doses, after full immunity, you got only 1 patient got COVID, so 1 by 12. That means risk in vax people is 1 by 12. So vaccine efficacy is measured like this, 1 minus relative risk. So 1 minus relative risk means risk in vax people divided by risk in unvax people. So we see risk in vax people is 1 by 12 and risk in unvax people is 1 by 4. So if I divide by this number, we'll get 2 by 3, that is 66.66%. So my question is, if you would do the same thing, for example, on the unvaccinated people, so everybody is not the virus prone, not everybody will catch the virus, because you see out of 12 only 3 people got the virus. So if we would apply the vaccine still during one I mean one dose time, we would see at least 2 of these COVID cases, right? I mean, in hypothetically, because uh, there is no way to isolate. I mean, before full immunity, how people uh, can avoid the virus? There is no way, right? So, in that scenario, you have to subtract the effect of the vaccine, right? So, people got the virus in unvax group. People got the virus 3, but in during one dose, so no matter what, if you vaccinate people, 2 people would get the virus. Say I'm thinking that the virus transmission is equal for vaccine and unvaccinated people. This number can make sense for a big number of samples. I'm talking a small number of samples so that it can easy to understand. So in that case, my understanding is that we have to subtract the this number like 2 from the vaccinated people. So people who got virus affected during one dose in the vaccination group, you have to subtract this number from the unvaxxed group. Then you will see the effect of the vaccine. If you do that, that means risk in unvaxxed group is 1 over 12, risk in vax group is 1 over 12, and if you do that, you will get 0% efficacy. So just think about it. This traditional calculation will tell 66% efficacy, and if you do this math, you'll see only 0% efficacy. Now, if you deal with a lot of numbers, you definitely that may not be very, what I'm saying here, but it definitely makes sense, right? Because say there are, I mean, probably I could talk about the real life data. For example, in Chile, I got that from a recent study, there is 12 million people. They did a study on 12 million people, and they found that the incremental percentage infection rate was higher for one dose people compared to the unvaxxed people. So if you do this calculation in my way, you will see the actually vaccine efficacy is, you have to calculate the effectiveness without vaccine. I don't know if you understand my word, but when you see the unvaxxed group, the COVID cases in vaccinated group, one dose is higher than the unvaxxed group. That means vaccine is not effective at all, but it without vaccine is effective compared to the vaccine to get rid of the COVID. And interestingly, if you see a lot of people get the virus during one dose, you will automatically end up seeing a small number of people getting virus in the vaccine group, right? Because say, for example, again, I can compare this one. Say there are 5 people, this is the vaccinated group, there are 5 people that are vulnerable to COVID. We don't know who is 5 people, but not definitely everyone will get sick. Say out of 12, 5 people will get sick. Now, if during one dose, if 3 people will get sick, then during second dose, say 2 people will get sick, right? So if you see during one dose, 4 people is sick, then perhaps in second dose 1 people will sick. That means the number of people increases in the first dose, the vaccine efficacy will automatically go up, because during the second dose you will get less amount of people. So it's definitely, there is a total misconception here, and this is the number everyone tells each other that vaccine works and things like that. I think we need to think about cleverly, and we need to seriously think about it, what is going on. Otherwise we will not be able to see what vaccine is doing. I hope you understand what I wanted to say. Thank you. Bye.